Good day, ladies and gentlemen. You are welcome to this channel. Today, we want to discuss the calculation that are involved in electrolysis. We are going to divide it into two parts. The first calculation aspect under the first law, and the second aspect is going to be under the second law. Please don't forget to like and subscribe to this channel for subsequent videos. Thank you. Let's go. Okay, calculations involved in electrolysis. Let's go. Calculation is involved in electrolysis. Now, the first law, as I've said, that the first part is going to be under the first law. The first law is between the mass involved or deposited and the quantity of electricity. So mathematically, that first law is stating that the mass deposited or liberated is directly proportional to the quantity of electricity. So mass is equals to Z Q when we introduce the constant sign. Where, let's define all our terms, where M is mass deposited or liberated at the electrode. Z is a mathematical constant called electrochemical equivalent. Mass is a mathematical constant known as electrochemical equivalent. That electrochemical equivalent is the mass of the substance liberated or deposited at the electrode by 1 coulomb of electricity. So the unit is always gram. The unit, that's the unit is gram per coulomb. That's the mass deposited or liberated at an electrode by 1 coulomb of electricity. That is what Z is. And Q is the quantity of electricity in coulomb. Q is quantity of electricity passed in coulomb in C. That is C. So at the same time, Q is the same thing as IT. Therefore, our first law can be restated as M is equals to ZIT. So now we are going to give some examples under this one. Let's take a look at this question. Question 1 that we are going to be treating, it states that 25 ampere flowed through a solution of copper 2 tetraoxide of CuSO4 for 1 hour 30 minutes 20 seconds. So using copper electrode, the question now says, what is the mass of copper deposited on the electrode, giving us that ECE of copper is equal to 0.00033 gram per coulomb. So don't forget, electrochemical equivalent is the same thing as Z, gram per coulomb. That is the mass deposited by 1 coulomb of electricity. So they are telling us that Z, so ECE, sometimes they might not write Z. Some students might be looking for Z. They didn't give us Z. Z has been given. Another name for Z is electrochemical equivalent, and it has been given. This question is a direct question because they are asking us to calculate solution. Let's go. Solution. What the question is asking us to calculate is M. What is the mass of copper deposited on the electrode? M is not given. What other things has been given? Z has been given. Z is the same thing as ECE. Z is given to be 0.00033 gram per coulomb. What else has been given? Are we given current and time? Let's look at it. I has been given. I, which is the current, it has been given to be 25 ampere, and the time has been given to be 1 hour 30 minutes and 20 seconds. That time should be in seconds, so we are going to convert hours and minutes there given to seconds. So we convert 1 hour 30 minutes to seconds, then we add it to the 20 seconds given already. So what we need to do is that we use M is equals to ZIT. We can substitute everything directly. Z is given to be 0.00033 multiplied by I, which is given to be 25 ampere, multiplied by 1 hour. 1 hour, that will be 1 times 60. We have converted to minutes. Then from minutes to seconds is going to be multiplied by 60 again. 1. So that 1 hour has been converted to seconds like that, plus 30 minutes. That is equal to 30 multiplied by 60. That one has gone. Then plus 20 seconds. That one has already been given in seconds. There's no need for conversion again. So if we solve everything correctly, we are going to get let me press the calculator. So we are going to get 44.72 gram. So that's the solution for that question. So for this particular question, passing this current for this time, it will deposit 44.7 gram of copper. Now let's treat some other questions. So if you see any other straightforward questions like this, you just solve it by using this formula. Now this is the aspect we really want to deal with. Number 2, the question says, now how many, look at these questions, how many Faradays of electricity are required to liberate 10 dm cube of chlorine at STP. That's 1. 2, the question says for 18 gram of aluminium. Then 3, let me use this 3, we can have let me choose this question 3, 2.24 dm cube of oxygen at STP. Maybe number 4, even if we are not going to treat all the question, 0.25 mole of oxygen, 0.25 mole of oxygen molecule. Now let's go and treat all these questions. So number 1, is 10 dm cube of chlorine at STP. Now before we go, there are some useful relations that we are going to tell us. NB 1 Faraday is equivalent to 96500 coulomb. That one is certain. And also 1 Faraday will liberate 6.02 times 10 raised to power 23 electron or particles. And at the same time, 1 Faraday, 1 Faraday. Okay, let's base it on this one. So, to do the first question. Now, you remember in our previous episode, when they asked us to explain the electrolysis of a certain compound, we usually write the anodic and cathodic reactions. Those reactions will tell us the amount of Faraday that we are going to use. The electron that are involved in those equations will be equivalent to the number of Faraday that we are going to use. Take for example, chlorine here. Before we can have chlorine like this, that will happen at the anode. It's going to be one of the anodic equations. So for us to have chlorine and for us to know the number of Faraday that are involved in getting one molecule of chlorine like this, that equation comes from when we have 2Cl. You remember we have written something like this before. That is oxidation. So it loses it and we have Cl2 plus 2 electron. In this case, when we have 2 electrons, that means 2 Faraday is needed to liberate 1 molecule of chlorine. It means i.e. 2 Faraday. So the number of electrons that are involved will tell us the number of Faraday that liberated a particular gas. You know this is a gas. So 2 Faraday liberated 1 molecule of chlorine. And at STP, standard temperature and pressure, 1 molecule of any gas will occupy 22.4 dm cube. Let me state it again. At standard temperature and pressure, it has been stated in the question. At standard temperature and pressure, a molecule of any gas, 1 mole a mole of any gas will occupy 22.4 dm cube. That one has given us a lead. So therefore, 22, this is a mole. That mole will occupy 22.4 dm cube. That 22.4 dm cube of what? Of chlorine It required 2 Faraday for us to get it. Required 2 Faraday. The question is now asking us 10 dm cube. How many Faraday will it require? I think the question has been solved like that. Therefore, 10 dm cube of chlorine gas will require, so we cross multiply 10 multiplied by 2, 10 dm cube multiplied by 2 Faraday divided by 22.4 dm cube. So when you press the calculator correctly, so we are going to get 0.89 Faraday. What has been done? That is it. It's very simple. So in this kind of question, what we need is to write the equation that are involved, just for us to know the number of electron, because the number of electron will tell us the number of Faraday needed for that particular question, and from there we can just relate and solve the question. Let's pick another question out of the question that we have, like this one. 18 gram of aluminium. 18 gram of aluminium. Question 2. 18 gram of aluminium. The question is asking us how many Faraday will be needed for this. For aluminium, for us to have aluminium deposited, that will be one of the cathodic reaction that will, because aluminium will have lost electron before gaining it. So gaining of electron is reduction. So we can have aluminium already will lose 3 electron plus 3 electron when it gains it. When it has gained it, that is reduction. Then we can have aluminium. So 3 electron, which is 3 Faraday, is needed for us to get 1 mole of aluminium. And a mole of aluminium, is 27 grams. So 1 mole of aluminium is equivalent to 27 grams. Please take notes. Some question might skip this, but when you have been working with it, you will get used to it. So because it's not given in the question, but we have to know some things. So let's go. We have already know that 1 mole is equals to 27 grams, and 3 Faraday was required. So we take it that 27 grams of aluminium required 3 Faraday. Then 18 grams, how many will it require? 18 grams of aluminium will require what? Will require X. That will be 18 grams multiplied by 3 Faraday divided by 27 grams. So let's press our calculator and do it correctly. You can have it 3 here 1, 3 here 9, 9 here 1, 9 18, that will be 2. So 2 Faraday will be required for this one. Let me do one more, then you do the number 4 as an exercise. You can get back to me if you don't get it. Just message me on my email for further solutions to your problem. So 2.24 dm cube of oxygen. That's number 3. 2.24 dm cube of oxygen at STP. This is similar to the first question that we have done. So as I've told you, we need to write an equation. If you can remember, where do we have oxygen as a product in any of those explanation we have given before? during the explanation of so many compounds, like during the explanation of acidified water, something like this come out. So during that, for acidified water, when OH is discharged, if OH is discharged, then we have an equation that looks like this: 4OH, 4OH. So oxidation will occur. Then we have 2H2O plus oxygen. This is where oxygen comes out. We remember that time I told you 4 electron was evolved. Since 4 electron was needed for us to liberate a mole of oxygen gas, then we have known the number of Faraday needed. Therefore, we just write our normal statement. So therefore, we have, and don't forget, a mole of any gas will occupy 22.4 dm cube. This is a mole, and it will occupy 22.4 dm cube. In fact, from the question, you will know which of the two things they want you to relate with 2.24 dm cube. They are talking about standard volume. It's here. Whenever they say STP, standard volume, then between volume and Faraday, you just relate them together. So far, you can write this equation. If you can write this equation successfully, then I promise you will get all the question. So we can have 22.4 dm cube of oxygen. It required 4 Faraday, isn't it? So the question now say 2.24 dm cube of oxygen gas. We require what? We just cross multiply. That is 2.24 multiplied by 4 Faraday divided by 22.4 dm cube. So if we do that correctly, we can get something like 0.4 Faraday, and that one has been done. I think you should be able to solve this. Number 4 is between mole. It's between mole and Faraday. You tell us a mole. It's even similar to this. A mole of Faraday required, a mole of oxygen require 4 Faraday. 1 mole of oxygen require 4 Faraday. Then 0.25 mole of oxygen will require. Then you solve it and you get the answers correctly. Then another part of the question is when they ask us the number of mole that are involved. Let's take 1 or 2 questions under that one. The question says calculate the number of electrons transferred by a 5,000 coulomb. B, the number of electrons transferred by these 1.5 ampere flowing for 3 hours. C, 1.025 Faraday. It's as simple as what I've written before. I've told you that 1 Faraday solution. I've told you before the relationship between Faraday, Coulomb, and mole. So I said 1 Faraday is equivalent to 96500 Coulomb, and also equivalent to 1 mole 1 mole of electron, and 1 Faraday, which is 96500 coulomb. 1 mole of electron is 6.02 times 10 raised to the power 23 electron. It depends on the one mentioned or particle. So when we have this, we have solved it. So we just relate them together to get the correct answer. So we can just do the number one. Number one, we know the procedure. 96500 coulomb gives us 6.02 times 10 raised to the power 23 electrons, because it's number of electrons. How many will 5000 give us? 5000 C will give, so you just solve it. That is 5000 multiplied by 6.02 times 10 raised to the power 23 divided by 96500. So we can go here. So it is as simple. We can have 5 times 10 raised to the power 1 multiplied by 6.02 times 10 raised to the power 23 divided by 965. If we solve that one correctly, we can get so we are going to get 3.12 times 10 raised to the power 22 electrons. That one has been solved correctly. So also this one, what they are saying is this: they didn't give us the coulomb directly, since we know Q. Number two, since we know Q is equals to IT, so Q I is given to be 1.5 multiplied by time is given to be 3 hours. That is 3 times 60 times 60. So when you solve it, you get the coulomb, and you relate it accordingly, just like this one. Then the last one also, Faraday has been given. It is given in Faraday. You just relate them, because 1 Faraday. For that number three, 1 Faraday will give you 6.02 times 10 raised to the power 23 electrons. So what else? Then how many will give this one give? 1.025 Faraday will give X electron. So you just cross multiply and do it correctly. I think I later have done all the questions. I want to give you this one as assignment before. But I have explained it. There's no more. So this is going to be the first part of the calculation that are involved in electrolysis. And our next episode is going to be calculation that are involved in the second law of electrolysis and the concluding part of the first law. Thank you for watching us. Please stay tuned. Don't forget to like and subscribe. Thank you. Bye bye.